Hello everyone. Today we discuss the equilibrium numericals. The first numerical is determine the tension developed in the wire CA and CB required for equilibrium of 10 kg cylinder as shown in the figure. Means what? Here this at the C point this cylinder of mass 10 kg is attached and one cable CB is attached in this position, which is having the angle 45 degree, and angle second cable is attached at the CA, which is having angle 30 degree. Okay, and we want to find out the tension which is developed in these two wires because of this weight. Okay, now first of all draw the FBD at the joint C. And here if we observe that these are the cables or wires, so here tension is developed, and for this tension means at the C point, if we consider the joint C and if we draw the FBD of joint C, then tension is away from the joint C like this for the CB, and for CA it is away from the joint C. So draw the FBD of this at joint C. This is the FBD. Okay, so this is the tension in the cable CB. This is the tension in the CA, and this mass 10 kg, convert that mass into weight multiplied by 9.81. So 98.81 is the force or weight. Okay, and these two cables or tensions having the angle with horizontal like this. Okay, which is given in a numerical. Now count the number of forces at the joint C. 1, 2 and 3 forces at joint C. So 3 forces under the equilibrium. So condition, these 3 forces must be concurrent or parallel. So here directly these forces are given at point C. These forces are concurrent. Now concurrent forces, so we can apply here Lami's theorem. Okay, for that Lami's theorem we want to find out the all the forces are away from the joint, and find out the angle in between these these 3 forces. Okay, so this horizontal line and vertical line which is having the angle 90 degree. Here also this angle is 90 degree, and forces we want to find out the angle between the forces. So 90 plus 40, that 130. This 90 plus 30, so complete is 120. And for this angle, complete is this line, dotted line, having complete angle is 180. 180 minus addition of 30 plus 40. Okay, means 70. So this angle we can easily get the remaining angle in between the TAC and TBC like this. So find out these angles and apply the use the Lami's theorem at joint C. Now see here the tension CA divided by sine of 130. Tension BC or CB is divided by is equal to sine of 120, and this weight divided by sine of 110 angle. Okay, now we want to find out the tension AC and tension BC. Okay, so if we equate these two, so we can find out this tension AC. Okay, because first and last, if we equate first and last, so here only one unknown, TAC is unknown, and if we equate the second and last, so here one unknown is there, that is the tension CB. So we can find out likewise. So first of all equate these first and last by equating these two. Now this sine 130, do the cross multiplication and take it in the numerator and simplify that. Do the calculation, you will get the value of tension AC, that is 80 Newton. Now after that equate these two. Okay, again do same calculation, take this sine 120 in the numerator multiplied by 98.1. okay, and simplified this calculation, do the calculation on your calc, you will get the value of TBC, tension BC, that is equal to 90.4, which is asked in the question. Okay, ये हमें दो question ये tension पूछे थे, so these are the answers. So first of all draw the FBD. Steps are FBD, count the number of forces, and according to that use the condition of equilibrium. Now next, second numerical. Two cables tied together at C are loaded as shown in the figure. Knowing that weight is equal to 190 Newton. Determine tension. There are the two sub questions. Tension first in the cable AC and in the cable BC. Okay, means here this diagram is given, and at the C joint one weight is given, 150 Newton is force is applied in this position, and because this to hold this weight like this in this position by this cable AC and BC. We want to find out again the cable tension AC and BC. Okay, so draw the FBD of joint C, count the number of forces, and apply the accordingly conditions of equilibrium. So first of all, draw the FBD of at joint C. Now to draw the FBD, here one cable and this is a wire or cable. So here tension is away from the C joint for this BC, and tension is again always away from the joint C for AC. And find out the angles of these cables with horizontal. So to find out the angle with horizontal, if we draw the line here, horizontal line, so this is the angle of AC with horizontal. So this opposite side is 16 given in the numerical, and this is 12. So opposite and adjacent. So we can apply to find out this angle, we can apply tan inverse of 16 divided by 12, we get this angle. Means if we draw the horizontal line here, so this angle and this angle must be same. Similarly for this cable CB, so this horizontal angle, to find out that, if we drop a vertical line from this point on this horizontal line, so this is the right angle triangle, and in this right angle triangle this side is 16, opposite side, and adjacent side is given 30 meter. So if we want to find out this angle, again apply the tan of 16 divided by 30 and take its tan inverse of that quantity, you will get this angle of CB, tension CB or force CB with horizontal, and here 150 Newton. So here in this right angle triangle, vertical side and adjacent side, horizontal side is given 8 and 15, and if we find out this angle, ये एंगल मतलब ये इस लाइन का, इस फोर्स का हॉरिजॉन्टल के साथ ये एंगल मतलब ये एंगल. सो वी वांट टू फाइंड आउट दैट एंगल. सो एंगल अपोजिट मीन्स 8 एंड एडजेसेंट मीन्स 15. सो tan inverse of 8 by 15 you will get this angle. So find out all these angle and then draw the FBD. Okay, so here FBD is likewise. At C, 4 concurrent forces act. 4, 1, 2, 3, 4 forces. Angles हमें पता है, हमने find out किया अभी. So 4 forces and all these forces are concurrent. So condition is that 4 concurrent forces. So we have the two conditions, summation fx 0, summation fy 0. And unknowns are, we want to find out tension BC and tension AC. So 2 equation, 2 unknown. We can find out this 2 unknown by 2 equation. So apply first summation fx. X means TAB, X component of TBC. So plus TBC cos of 28.07. This forces lies in the second quadrant. So minus towards left side, minus TAC cos of 53.13. This forces lies in the third quadrant. So again this X is towards the minus towards the left side. So minus 150 cos of 28.072. And this force is vertical force. So X component of 190 is 0. Okay, don't write that component because that is 0. So simplify that equation and write here equation number 1. Okay, ये जो है हमें ये भी simplified करना है. Now here BC and tension AC both are unknown. So by one equation we can't solve that. So keep as it is. Now apply the summation Fy. Vertical component of BC, that is plus TBC sine of 28.072. Vertical component of AC again plus TAC sine of 53.13. this force lies in the third quadrant, so vertical component is downward, minus 150 sine of 28.072, and this is minus 190. Again simplified that, again do the calculation or ye simplified karo, and we have the equation, again one equation which is having the unknown BC, here BC, tension AC, here AC. Okay, do the calculation or simplified this two equations, solve on a calc, we get the tension BC value and tension AC AB value like this. Okay, so these are the two answers. Now next question. The 500 Newton crate is hoisted using the rope AB and AC. Each rope can withstand a maximum tension of 2500 Newton before it breaks. If AB always remains horizontal, determine smallest angle theta to which crate can be hoisted. Refer the figure. Now here the figure is given, and that this weight is having 500 Newton, and given that always this AB remains in horizontal position, and because of this weight this cable can carry maximum weight, maximum tension of 2500 Newton before it breaks. Means what? If the tension is increased in these two cable AB and AC, if the tension is increased greater than 2500 Newton, then these two cables are break. Means that this diagram or that given figure is not in equilibrium. So to maintain this equilibrium, so that tension in these two cable not greater than or not exceed than 2500 Newton, and find out this angle theta for that cable AC to maintain the equilibrium. Okay, now draw the FBD of this given figure at point A. Okay, so to FBD, this is the force or tension in the AB, tension AC, which is having the angle theta, and this is the weight. Now apply the here Lami's three forces under equilibrium. These forces are concurrent, so we can apply the Lami's theorem. Now this angle in between the AC and B, this complete is 180, so this is 180 minus theta, this is 90, and this complete is, this is angle 90, so this is 90 plus theta. Okay, now apply the Lami's theorem. Okay, by Lami's theorem, TAB divided by sine 90 plus theta, TAC divided by sine 90, and 500 divided by 180 minus theta. Okay, now what is that? Sine 90 plus theta means cos theta, and sine 180 minus theta means nothing but a sine theta. Okay, now simplify this equation likewise. Okay, and this sine 90 is 1. Now we want to find out this tension AB as theta. Okay, by using the value of tension AB and AC is 2500 Newton, because maximum value that can carry is 2500 Newton. So by equating first and last, we have the one equation, that is cos theta, sin 90 plus theta means cos theta, and last equation 500 sin 90 minus 180 minus theta is sin theta. Okay, and here by equating second and last, so second sin 90 value is 1 and this value is sin theta. Now using that sign, again simplified that, so we that is means find out the equation in terms of tension AB and tension AC. Okay, so sin, this sin divided by cos, that is equal to tan theta. So this equation is this one, and this is simplified equation TAC. Now we have the value of tension AB and AC, that is maximum value 2500 Newton. Find out this theta by equation number 1. Find out the theta by equation number 2. And to cross verify that which value of theta is correct, if we get the theta from this equation 1, put this theta here and find out the what is the value of TAC. Similarly, find out the theta here and put this value theta in this equation and find out the value of TAC. Cross multiplication. Okay, so that first of all, by this equation, take this TAB is equal to 2500 Newton, put this here and calculate the theta. So we get the theta is 11.31 degree. Now to cross verify this angle is correct or not, to cross verify that, put this theta in this equation, find out the TAC by the second equation. So by putting this theta here, the tension's AC value is 2549.5 Newton, which is greater than 2500 Newton. मतलब यहाँ पे ये वैल्यू ग्रेटर है 2500 से, तो ये थीटा नहीं हो सकता क्योंकि यहाँ पे ब्रेक हो जाएगी केबल और वायर. सो ये थीटा नहीं हो सकता. इसीलिए हम क्या करेंगे, यहाँ से थीटा फाइंड आउट करेंगे और यहाँ पे प्लेस करके देखेंगे कि करेक्ट आता है कि नहीं. नाउ सेकेंड, दिस वैल्यू TAC is 2500. Equation is this one. Okay, put this value here, find out this theta. Okay, likewise. Now theta is here 11.53. 11.53. Now by putting this theta in the equation number 1, find out the value of tension AB, which is having the 2449.48 Newton, which is less than 2500 Newton. So theta is equal to 11.537 degree, which is the correct value. Now next equation, next question. 3 cables are joined at junction C as shown in the figure. Determine tension in cable AC and BC caused by weight of the 30 kg cylinder. Now here this diagram is given. Okay, in this diagram we want to find out that tension in the cable AC and tension in the cable BC. Okay, and 30 kg pipe is attached like given, which is given in this figure. Now this 30 kg pipe is hold in this position due to this pulley. Okay, now here pulley or spear. Now here this friction is not mentioned. Okay, so this is a frictionless, means what, for this pulley, this tension and this tensions both are equal, and that is equal to 30 kg into 9.81, that is the weight of this cylinder. Okay, so draw the FBD at the point C by using this tension, and here the angle of AC and BC, that is given in the numerical. Okay, use this angle to draw the FBD. This is equal to 30 into 9.81. So same tension here, and for this C, tension is always away from this joint C. So 30 into 9.81. Angle is 15 degree, that is given. Here the angle of this vertical AC with vertical 45 degrees. So this angle is 45 degree. And this cable BC is having the angle 30 degree. So this is 30 degree. Now find out the angles between that and apply the Lam's theorem. 3 forces equilibrium, so we can use the Lam's theorem for concurrent forces. So TAC divided by sine of 135, TBC divided by sine of 120, and this value weight divided by sine of 105. So by equating first and last, we get the tension AC. By equating first and second and last, so we get the tension BC, which is asked in the numerical. So these are the 2 answers. Now next one, a 300 mm wooden beam weighing 540 Newton is supported by a pin and bracket at A and by cable BC. Find reactions at A and tension in the cable BC, refer figure. Now this beam, AB beam, which is having the at point A, is that is the hinge or pin. ये pin से connect किया है, and to hold this beam in this horizontal position with the help of this cable or this wire. Okay, at point B and point C. Now we want to find out the tension BC and reaction at the point or joint A. So first of all, draw the FBD of this beam A beam. Now here this weight 540 is attached exactly at the center. Okay, from A point 150 and from this side 150. Now here because of this attachment at B point, tension is developed at the B, which is away from the which is along the cable, and which is direction is away from the point B. Now we want to find out the tension angle with horizontal. So use this geometry. This opposite side, if we want to find out this angle, opposite side is 150, adjacent side that is 210 is given. So tan inverse of 150 divided by 210, we get the angle of tension BC with horizontal. And hinge point or pin point, so there are the two reaction, one horizontal, one vertical, okay, AX and AY. So draw the FBD. This is the FBD of beam AB, okay, for this figure. Now count the number of forces, 1, 2, 3 and 4 force, which are not 4 and more forces, and these forces are non-concurrent forces, okay. These are the parallel force, this point, this force is at point B, means अलग अलग point पे है, concurrent नहीं, एक point पे नहीं है. So here we have the three equations, summation fx 0, summation fy 0 and moment equation. So एक एक करके हमें तीनों equation apply करने हैं, and unknowns are tension BC, AX, AY, 3 unknown, 3 equations, so we can solve this. So apply the first condition, okay. Now theta, यहाँ पे ये जो है एंगल अल्फा, ये हमें कैसे मिला, tan inverse of 150, suppose this angle is alpha, so 150 divided by 210, tan inverse of that quantity 35.454 degree, okay. So we can calculate angle and apply the one by one equations. First of all, this two tension, okay, that is splitting of this tension in horizontal and vertical direction. So these are the two values, okay. So x is with theta is with x-axis, so this must be cos and opposite is sine. Now apply summation moment first equation at point A. If we apply the moment equation at point A, AX and AY are passing through the point A, so both forces moment are 0 because perpendicular distance is 0. Now this horizontal component of tension is also passing through the point A, so this moment of this T cos 35.454, that is also 0. इस force का horizontal component जो tension का, उसका भी moment 0 आएगा क्योंकि ये इसमें से pass हो रहा है. Now remaining is 540, which is the vertical, and this is also vertical. So vertical, for this vertical force, horizontal is the perpendicular distance. For this vertical force, this is the perpendicular distance, horizontal, okay. Now this 540 is rotating clockwise, so minus 540 into 150, and this vertical force is rotating anti-clockwise, so plus sine T sine 35.54 into 210, okay. Now simplified this, here only T is unknown, so simplified this and find out the value of tension. So पहले हमें value मिल गई tension की, tension BC की value. Now apply the second equation, summation fx, AX minus T cos 35, okay. T की value हमें मिल गई, so put that and simplify that, you will get the AX is equal to 540. Again Fy, summation next equation, summation Fy is equal to 0, so plus AY minus 540 plus T sine 35.54. Now here put the value of T from the first equation and simplify that, you will get the AY, this one, okay. Now observe this AX and AY, horizontal and vertical reaction. We want to find out the resultant reaction at A, so that formula is RA is equal to, from first unit, that is equal to AX square plus AY square. By putting these two values, you will get the RA, resultant reaction magnitude, and for direction use this theta A is equal to tan inverse of AY upon AX, you will get the theta, okay. Now this RA is in which quadrant, so with the help of AX and AY sign we can find out the quadrant. Here AX is plus, AY is also plus, so RA lies in the first quadrant, so this is the symbol of first quadrant, and this is the theta with x axis. ये x के साथ क्यों है, because यहाँ पे हमने डिनोमिनेटर में AX रखा है, इसलिए x के साथ है थीटा. So these are the answers. AX भी मिल गया, AY भी मिल गया और T भी मिल गया. Thank you.